Hey, hi again, and welcome to this new section of the course. And in this section, you're going to build the second application of the course. And specifically, what you're going to build with Python is this web map that you see here. So a web map is a map that is displayed through a browser and can be visited through the web. So this map was built with Python and Folium. Folium is a Python library, and the map has three layers. It has a base map layer, the one that you see here, with its names on the back, and it has a polygon layer, which represents the population of the countries, and also we have this point layer here with these dots, and you can turn on and off these layers. You also have these pop-up windows. So this is what you're going to build, and yeah, let's go ahead and do this. See you in the next lecture. Hi again, I hope you followed the previous video where I presented to you the map that you're going to build in this section. So that was a web map, and as you may realize, to build that web map, the default Python installation is not enough, because logically, Python cannot have every possible functionality by default, because if it had all the functionalities, then Python would become very heavy. Therefore, it's a smart choice to have external libraries that you may choose to install or not. And this is the case of web mapping. So to build the web map that I showed you in the previous lecture, you need a library, a third-party library, which is called Folium. So as you may realize, you need to install that library. Now, just a note, I had some previous videos about this section, some old videos, but I had to change them, so I'm recording new videos now. This is a new video, updated video, and all the next videos of this section, because Folium had made some changes in the code compared to the previous versions, therefore I had to remake the videos. Now, this time I'm using a Mac computer, but that will not make any difference. So if you're on a Windows, Linux or Mac, everything will work exactly the same. The only difference is the way you open Atom, of course. So on Windows, please create an empty folder where you'll be keeping the files for this project. So my folder here on Mac is mapping, and on Windows you can hold the Shift and right click, and then go to Open Atom here, to open Atom in this folder. On a Mac, you can press Command space Atom, and then go to View, Developer, open in Dev mode, and then locate the folder and click Open. And yeah, that's it. I'm going to close all this. Let me open the terminal. And now go ahead and install Folium. To do that, you need to type pip install Folium. Normally you'd have to do this on Windows. On Mac, if you have two installations of Python, you may need to do pip3. So that will explicitly say to install Folium for Python 3. So Folium was installed successfully. If you have a message saying that Jinja 2 is required for this package, then just go ahead and do pip3 install Jinja 2. However, I expect that Folium will install Jinja 2 by default, as it did for me, so it should be good to go. Once you've done that, I'm going to open Python, actually Python 3. On a Mac, you need to specify Python 3 explicitly. And what I'm going to do now is I'm going to create a basic web map. And I'm going to use a Python interactive shell for that, so that I show you things around. So try to import Folium. If you get no errors, that means Folium has been installed successfully. Now, how does Folium work? Well, everything spins around a so-called map object. So the very first thing you need to do once you import Folium is you need to create a map object. So I'm using a variable to store that map object, and then equal to Folium.map. So this is the class that creates this object. If you want, you can actually check dir Folium to get a list of available objects that you can use on Folium. So here is map. Ignore the others for now, we'll go through them later. You can also ask for help now, Folium.map, to see what you can pass to this map object. Create a map with Folium and leaflet.js. So what Folium does is it actually produces, you use Python, so you write Python code, and that Python code will convert automatically to JavaScript and HTML code and CSS code. Because you need JavaScript, CSS and HTML to create web maps. You cannot do that with Python code directly. So the browser reads HTML, CSS and JavaScript and renders the code of these three programming languages to elements, so like text and lines and points and pictures. So that's what Folium does. And that's a wonderful thing that you can do that with Python, through Python. Anyway, you can look here, down here in parameters. You can pass a location parameter in here. And you can specify the width. Anyway, if you don't specify the width, a default width of 100% of the browser area will be used. So you don't have to pass width and height as well. And then you have tiles. Default is OpenStreetMap tiles. So tiles is the background of the map. You're going to see that in a minute. You have other parameters as well, which you can look by yourself, I believe. Okay, I pressed Q to exit the help, and let's go ahead and create the map object finally. Folium.map. So location, you need to pass a location parameter there so that the map knows where to open. So it may open, let's say, near Alaska or near Greenland or South Africa. We're talking about the initial view, but then you can zoom in and out. So let me pass a random location. Locations, by the way, are given through coordinates, and by default you need to pass geographic coordinates, which is latitude and longitude. And so latitude ranges from -90 to 0 to 90. So let me pass 80 there. By the way, this goes inside the list actually. So 80, a comma, and then the longitude. The longitude ranges from 0 to -180 and 0 to 180. Let me pass -100 and close a bracket. So you pass a list of coordinates to location. And actually that's enough. You can have a map object with that. Execute, you don't get an error. That means everything is working fine. So now you have a map object, but that's just an object inside Python. You haven't translated that object into HTML and CSS and JavaScript code just yet. So what you need to do next is point to that map object and then use the save method and then pass a name for the map file that will be created. And of course the maps will be created in HTML format. So HTML is what contains all these elements that render on the browser, so text and visuals and so on. Close the bracket, execute, and as you see, a file was added in here, map1.html. But let me go to the folder, double click that, and that will open in your default browser. So this is just a random location, I don't know what it is. Magen Island. And that seems to be in Canada, very north of Canada. Yeah, this is it. This is the web map. If you zoom in, you'll see more details on the map, like that. So the more you zoom in, the more elements you see. And yeah, that's what I wanted to show you. And if you want another location, you'd want to change the coordinates in here, in location. But if you don't know what coordinates your favorite place has, then there may be different ways to discover that, but a quick way is to go to maps.google.com. Let's say you want to know the let me zoom in here. You want to center the map around this location, so right click there and go to what's here, copy these coordinates, copy those coordinates, or if you cannot copy them, just remember them. So 38.58 approximately, and minus 99 times 09. Okay, then you need to save the map again, map1.html, and that will override the previous map. So go here, reload, and you see now we have a different center of the map. And of course you can also play around with the zoom, so you can add a zoom parameter in here. This is called the zoom start. Let's put it at 6. Don't forget to close the brackets in here. Okay, execute. Upper arrow key to call a previously executed statement, like map save. Well, you can also choose to go to the browser and reload with Control R or Command R, and that will show you the new map with another zoom factor. And yeah, that's about it. Try to play around with this a little bit, and in the next lecture I'll show you how to add points to this map. I'll see you there. Hi again, and welcome to this new lecture. In this lecture you're going to learn how to add points to the map that we built previously, which is this one here. So all we have here is a base map, so the background map, which is a layer. Actually, it's a layer coming from OpenStreetMap service. So OpenStreetMaps, they give you a layer. Actually, Folium will serve you this layer on the background through JavaScript. But you can also add other layers as well, other base layers, and also points, which you can add on top of the base layer. So let me go back to the code. This is what we wrote in the previous lecture. Actually, we wrote it in here, in the interactive shell, but I just copied and pasted this in a file so that we have it and that we can add more code now on top of this. So again, as I told you, you can do help folium.map, and you see you can add other things in here. Such as, here you have the parameters, so you can add tiles. The default is OpenStreetMaps, but if you specify another tile, such as map box bright, and that has to be in quotes, as you can see in here in the tiles parameter, this expects a string object. Location, for instance, it expects a tuple or a list, and that's what we passed. We passed a list of coordinates. The width would be an integer, the height, and so on. You have other options as well, which you can try by yourself. I just want to try this one for now. Let me open a new Python shell. Python 3 map 1. Make sure you have saved your script. Execute. Then you can go back to the folder and open map. Let me go to Firefox, Ctrl R or Command R to reload. And you'll see that the background has changed, so we have a new base map now. Okay, let's go back to the script now, and what I'm going to do is I'm going to add some point markers on top of the base map. And so how do you do that? Well, if you do dir Folium, here you can see that you have some objects, and the one we want is a marker or a circle marker. So I'll try them both, but I want to explain you the logic of how you add objects to the map object. So we import Folium, we create a map object, and then between the map object and the save method of the map object, you can add elements, so objects to that map. And what I want to add in this case is a marker. So I can do map dot add child. So we use the add child method to add children. So these objects that I'm talking about are referred to as children when you add them to the map. So map add child, and then you want to point to the Folium dot marker. Now this marker method, this expects some arguments itself. You can do help Folium dot marker. So create a simple stock leaflet marker on the map. Leaflet is a JavaScript library that helps you to visualize this. That is the engine that creates those maps on the browser. So Python creates a JavaScript code using the leaflet library. And so markers allow you to add pop-ups. So when you click a marker on the map, it allows you to show information. And so parameters, you need to pass a location parameter to the marker in order to visualize it. So location equals to, so it's a tuple list, let's say 38.2 and minus 99.1, and you can also pass, so after the list, a pop-up parameter, which could be like, hi, I'm a marker. And you also need to pass the icon parameter, which actually is another object, and that comes from Folium.icon, which expects for me to pass a color there, like let's say green. And yeah, basically that's it. Make sure your brackets are correct. So I have 3 brackets here, 3 closing brackets, and 1 and 2 and 3 opening round brackets. Okay. Save the script. Go to the other terminal and execute. Go to Firefox, reload. And here is the marker. If I click, I get the pop-up message in a nice window here. So that's how you add markers to your map. However, I would suggest you follow a slight different approach to add children to your map. What I would suggest is to actually create a feature group, Folium.feature group, and you can give it a name like my map. And then what happens is that in this feature group, so the marker is a feature, and with feature groups you can add multiple features to the feature group. So you can add a marker, you can add like polygons, etc. And so instead of saying map, you do the feature group object So this variable that I created in here, I'm passing it here. And then after that, you do map.addChild, and you pass the feature group in there. So this is done to keep your code more organized, and it also helps you later when you want to add a control layer control feature in your map to allow you to switch the layers on and off. So we'll look at this later. Save this script and let me try it. Reload the page. And so we don't have any change. Things will work the same, which means feature group is working fine. But as I said, it's good to keep the code organized, and it also helps you later when you add a layer control feature. That's what I wanted to teach you for now, and I'll talk to you later. Great, we were able to build this map in the previous lecture. So we have a base map and we have a marker feature here. And this is our code. Now in this lecture I'll show you how to add multiple markers to your map. And the way to do that is to, one of the ways to do that is to write this expression multiple times. So like that, and of course you need to change the locations of those markers. Save the script and execute, reload, and so you have multiple markers. So as you realize, it's not possible to add multiple markers with one single method. So with one single marker method, you need to apply the method multiple times. However, this is not very smart to do. And that's the beauty of programming. You can use a for loop to actually add multiple markers to the map. So we're talking about the Python for loop, which is one of the fundamental features of Python. So the for loop has nothing to do with Folium. Let's say for coordinates in, of course you would need some sort of input with the coordinates. I don't know, let's say like that. Let's say a list of lists. So we have these two coordinates. Let me copy this, put it there, and another time, and let me change them to 9 and 7. And then you need to indent this with 4 white spaces. I'll explain this in just a bit. And then in location, you need to pass coordinates. Before explaining the code to you, let me try this out. Execute. Go to reload. And yeah, we still have the markers there. Of course, the location changed from the previous one because I changed the coordinates in here. So how is this working? Well, I'm iterating with a for loop through this list of lists. So the items of this list, of this main list, are 2 other lists. So the items can be anything. In this case, there are 2 lists. So what happens is that the coordinates variable, in the first iteration, it will get this first item of the list, and it will put that small list, so 32.2 minus 99.1, it will put that list in here. So basically this will be put in here, more or less. That's the idea. And then in the next iteration, coordinates will fetch this other list, and it will put it in here again. And so the marker method will be executed 2 times. And so the first time it will generate a marker with these coordinates, and then in the second iteration it will generate a marker with these coordinates. And that's it. However, we have a small issue here, and the issue is that, in reality, you cannot just type the coordinates in a Python list. Let's say you have 1,000 coordinates that you need to map into a map. And you cannot, and it's hard to type them in here or even paste them copy and paste them from a document in here. So the solution to that is that your coordinates normally in real life, they will come as maybe a text file, like a comma separated text file, CSV, Excel files, etc. And you want to load that file into Python, and then you want to add the values of that file into the marker method. And you can do that using a for loop. And how you do that exactly? Well, I'll explain that in the next lecture. Well, I'll give you a comma separated file with lots of coordinates, and we're going to use that in this script. So I'll talk to you later. Hello, in the previous lecture you were able to build this map with multiple markers. This map happens to have only 2 markers, but you get the idea. And the script was this one here, so you can add as many coordinate pairs as you want in here. But in this lecture I want to show you how to add pairs of coordinates out of a text file, which is this one here, volcanoes.txt. If you like, you can just rename the name of this from volcanoes.txt to volcanoes.csv, and then you can open it in a program such as Excel. If you like, you can show it on a plain text file, as I'm doing in here. Python can read both CSV and text files. So what we have here are some data about volcanoes. Basically, we have the number of the volcano, which is some sort of ID. So volcano 020. We have yet another number then. And as you see, every column, so we have columns in this data file, and every column is separated by a comma. This is the name of the first column, the first value of this first column is this one here. Then is the name of the second column. The first value of the second column is this one here. Then the second value of the second column is this, and so on. And then we have the name column, the name of the volcano in here. The name is here, Baker, and then the comma starts here, which means that location is this one here, US Washington. Then we have the status historical for the first volcano. And then we have the elevation, which is this one in here. I'm not sure whether these are in feet or meters, but you can find that out. If you're curious, you can do a research for this particular volcano and compare the elevation. Anyway, then we have the type of the volcano. You have the time frame, which is D3. I'm not sure what this means. D4. And so then lastly, this is where we're interested about. We have the lat and lon columns. So this is lat, which means latitude, and this is longitude of the volcano. So you need these 2 numeric values in order to map the features, so the volcanoes, into a map, in this case into a Folium map. So this has around 63, actually 62, 63 including the header of the data. And so how do we load this file into Python? Well, to load that file into Python, let me clear the terminal. And you'd first need to install a very useful library called pandas. We're going to use this library later on, so I'm not going to explain pandas in detail for now, because we were just using 1 or 2 of its functions, which I'll explain in this lecture. So go ahead and install pandas if you don't have pandas. Pip install pandas or pip3 install pandas, depending on how you have configured Python. And then you can go ahead and open a Python session. Import pandas. And the way to load a file with pandas is by pointing to pandas.read CSV volcanoes.txt. Make sure that your Python session has been opened in the directory where your volcanoes.txt file is. So for instance, my session is inside mapping folder, which is this one here, so I can just pass the file name. Otherwise, you may have to pass the absolute path of the file, which starts from like C // and so on, depending on what operating system you are in, and execute that and call data, and you get the data printed out, just like that. So pandas is able, actually the read CSV method is able to distinguish between these commas, where the commas are, and so it creates a well-structured data format with columns. So if you go down here, so you have some columns here, column, and then up to the end. And then you have other columns because Python cannot print out. Actually, the terminal doesn't allow you to have all the columns in one inside with this area here because it would be too much. Anyway, you have status, elevation, type, time frame, lat, and lon. So that's about the data. Now you need to figure out a way to iterate through that data frame. So this is called a data frame. So the data object is called a data frame. You can check its type actually. Pandas core frame data frame. So what I'm thinking of is to actually create two lists out of these data frame columns. So to put the latitude column in a Python list and the longitude column in another Python list. And so that we have a native Python object, which is a list, and then we can iterate through that list using the for loop. So let me try to do that. Import pandas, and then create the data frame object. So loading the data, read CSV volcanoes.txt, and yeah, that's it. So how do we convert a data frame column into a list? Well, the way to do that is by just doing, let's say L or lat equals to data, and then the name of the column, which is lat. So you can get a list of columns, by the way, by doing data.columns. Here you see you have a lat and a long column. Then you do lat equals to list data lon in square brackets, close it. And so what you did here is data with the lon attribute there will return a series object, but that series object we are converting it into a native list. So that will be a Python list. This will also show up as a similar object. So this is a series object, and this is a list, but I prefer to work on a list because working on lists is faster than working on data frame series. So the idea is to have two lists here. That equals to list data lon. Copy that, paste it here, and the same thing goes for longitude. So lon, lat, and lon lists. So now we need to be careful here on how we iterate through these two lists, because you know what we have is we have two lists, and each of them has 62 items. You can check that using len here, down here, lat. So it has 62 items, and the same goes for the longitude list. That means that the first item of the latitude list corresponds to the second item of the latitude list. Of the longitude list. So the first two items make up the first location of the first marker. That means that in the first iteration we need to extract both locations. So actually this sort of structure won't be appropriate anymore. What you need to do is you need to go through, let's say, lat and lon variables. When you iterate through two lists at the same time, you need to use the zip function. And then it goes lat and lon. So basically what this function does is like this. Let's say for I, j in zip, let's say the first list is 1, 2, 3. And the second is 4, 5, 6. Print I and j. So this is what happens. This loop will go through these two lists at the same time. So what happens is that I will go through the first item of the first list, while j will go through the first item of the second list. And so in the first iteration, 1 and 4 are extracted. So 1 here and 4 here. And you can do such an extraction by using the zip function. Otherwise, you won't be able to do that if you don't use the zip function. So zip sort of distributes the items one by one. And so the same goes here. LT will get the first item of this list. L1 will get the first item of this list. And then here, what you need to do is you need to construct a list with LT and LN. Yeah, that's it. Save the script, go to the terminal to execute. It's not here, the terminal. I'll just exit that. Python 3 map1.py execute. No errors. Go to Firefox and reload. And I've got no markers for some reason, but I didn't get an error. So this is one of those scenarios where you don't get an error in the terminal. So in that case, you need to double check your code carefully. So data pandas 3 CSV lat list data lon. Here's the error. So what's happening is that I'm assigning the wrong column to the latitude list. So let me change the order and try again. So don't get intimidated by errors. Errors happen all the time. You just need to be cold-blooded and read the errors if you get any error here, and also look at the code carefully. And let me reload. I've got some markers now. So these are the locations of the volcanoes in US actually, United States. Okay. They also have this pop-up, which is working well, but I assume you don't like it very much because it's not showing any information. So what we need to do here is to actually make this pop-up dynamic so that it shows some actual information. And I'll show you how to create dynamic pop-ups in the next video. Talk to you there. Hi again, in this video I'm going to show you how to add the elevation values, so these ones in here, to the pop-up window. Currently our script simply prints out this string in the pop-up window. So we're going to change that, and the way you do that is by first loading the elevation data into a Python list. And then in the loop here you want to say, let's say L in zip lat lon elev, like that. And here in the pop-up argument you pass the L attribute. So again, we create a list which is named elev, so variable elev. That will be a list of all the elevations, and then we iterate through these three lists So LT will get the first item of let, LN will get the first item of lon, L will get the first item of LF, and those items will be distributed in this function in here. So LT in here, LN in here, and L in here, EL in here. Now I want to save this and execute, but I expect to get an error. And I want you to see the error so that you get familiar with handling errors as well. So the error is happening on line 14 in this file, map1.py, which is our file. Line 14 is here. So this is the line. And then we have add child pop-up. So it seems this error has to do with the pop-up object. I would say this is not a very good error message actually. It's hard to read this error and to troubleshoot it. So not very good information given by Folium here. But anyway, we have some clues. So pop-up. And this says name child get name attribute error numpy.float 64 object has no attribute get name. So it seems that Folium is trying to apply this getName method, which is a method inside the Folium code base, and it's trying to apply it to a number. So I think that this L here is actually a number, and I can check that by saying print type L, save, execute the script, and yeah, here is the type. So this is a numpy float 64. So basically it's a float type. It's actually a special float of the numpy library, but anyway, you can call it a float. So it's a number, it's not a string. But if you look at help Folium marker, you'll see that the pop-up parameter expect a string from you as input, but instead you're passing a float number. So you don't want to do that. What you want to do is simply convert that float number to a string. Save the script, go to the terminal, execute again, go to Firefox, reload, and you get the elevation displayed correctly. Yeah, that's about it. You can also you may also want to stylize what you're displaying, so to add more information there, such as plus space meters. So I'm adding the M string to every pop-up window information for all the elevation numbers. So we're talking about 2447.0 meters. That's the elevation of the volcano. Yeah, that's the idea. I hope this was clear, and I'll talk to you later. Hey, hi again, and welcome to this new lecture. What we have so far is this map with these 62 markers, each of them representing a volcano location in the United States. However, this map is not very smart, so to say. The only information that this map conveys is the locations of the volcanoes. And you also have a base map. There's also a good aspect of this map because you can extract information like that if you click the icons. However, you may want to transform this map to actually show an attribute instead of just volcano locations. The way to do that, there may be different ways, but that's up to your knowledge about cartography. But I could make the map show an attribute here. For example, I could change the colors of these markers to actually show the elevation range. Let's say we can categorize these markers into 3 colors. Let's say green, orange, and red. Green would be for elevations from 0 to 1000 meters, for example, or 2000 meters, and orange would be from 2000 to 3000 meters, and then red markers would represent volcanoes with an elevation of higher than 3000 meters. So how do we do that with Folium? Let's get back to Atom. Here is our code, what we have so far. Currently, what we're passing to the icon argument is a color argument with a value of green. So basically what we need to do, we need to make this dynamic so that the color changes depending on the elevation. And unfortunately, we cannot do that with Folium. So Folium doesn't have native functionality to create dynamic colors for your markers. Therefore, we need to be a bit creative here and use Python core functionalities to do this. And when you think about dynamics, I think about functions. So basically, this loop is going through latitude, longitude, elevation, and then it passes those 3 values into this expression in here. However, color is being passed as a string always. But how do I change it depending on the elevation, for instance? Well, the way to do that is by creating a function that gets as input elevation, and then it does some actions inside the function, and then it returns a color depending on the elevation value. So you can say, if elevation is less than this, give me green color, a green string here, and so on and so forth. So to give you an idea, the way this would work is, let me write the function here. This would be a good place to do that before creating the map object. But always you need to create the function, because I will be calling the function in here. So you need to create the function before this expression. So from here and upwards. I'll be creating that in here. Let's call the function color producer. Let's keep it simple for a while just to demonstrate you how this would work. So let's keep it very simple. Let's say return green, and if you change this to color producer, and don't forget the brackets, by passing brackets that means you are calling the function. If you don't pass the brackets, that means you're just calling the function name and you are not executing the function. So just keep it like that and go ahead and execute map1.py. Alright, reload and you'll get the same thing, right? Because what happens is that this thing in here, this function call, will be equal to whatever you return here. So the type of this object is actually a string. So it's exactly the green string. Therefore now you can add some conditionals here. Basically you need to pass an input here, so elevation. Let me write whatever variable you like. I'll write elevation, and here you need to pass L. So L for lat lon L. So, let's say we have 62 rows in the data table, and for loop will go through the first row of the table. It will get elevation and it will pass it to this function call. So the function will pass L into elevation, and then you say here if elevation is less than 1000, then you want to return green for elevations less than 1000 meters. If elevation is between 1000 meters, so it's greater than 1000 meters, or less than, let's say, 3000 meters, return orange. Else return red. So red will be returned if none of these conditionals is satisfied, which means elevation is neither less than 1000 meters nor between 1000 and 3000 meters, which means what is left is greater than 3000 meters. In that case, we will return red. For finding out those values, actually, you need to do a little bit of data exploration. For instance, you may want to look at the data quickly like that to see what values you have, and then decide on the category thresholds. But you can also make more significant statistical analysis, like you can make a histogram and see the data distribution and then decide on these values. But let's keep things simple and let's decide on these values. Okay, I'll save this, check if everything is in place just quickly. Yeah, let me try the code. Go and reload. And yeah, we have some different colors here. Yeah, this is looking good. Let me double check the values. For instance, orange is between 1000 meters and 3000 meters, so we're doing good. Red is above 3000 meters. Yeah, it seems it's working. Alright, I hope you solved the exercise, but don't worry if your map looks a bit different from mine. Anyway, here are my markers, circle markers actually, and I have green, orange, red and orange markers. You get the idea, and they also have some sort of opacity. So I have set an opacity value of 0.7, which means 70% to them. As you see, you can see the marker that is underneath this one here. Anyway, here is the code. So let me explain what I changed from the original code. So I changed marker to circle marker. The location remains the same. Also pop-up attribute remains the same. And then I added a radius here of 6, which means 6 pixels. That's the size of those circle markers. Then I added a fill color. The fill color attribute is for the inner area of the circle. So you see this orange area, but you also have this outer color here, which I set to gray, and you do that with the color argument. So color equals to gray for all of the markers. The default color would be black, which I think is a bit heavy for the eye. Anyway, here is the fill opacity. For the transparency, I set it to 0.7, and that's it. I hope this is clear now, and I'll talk to you later. Hi, welcome again, and in this lecture, I'll show you how to add another layer to this map. Currently, we have two layers. We have the base map, which are map tiles by map box, you can see here. And the data are served by OpenStreetMap. And you also have your custom layer as well, which is a layer containing circle markers. So in GIS, Geographic Information Systems, these are referred to as layers. Now I'd like to add a third layer to my map. That will be a polygon layer. So this current layer with markers, this can be referred to as a point layer. You also have line layers and polygon layers. So with points are better to represent locations, and you have lines. Lines are best for representing geographical features which resembles lines, such as roads and rivers. And then we have polygons. Polygons are best to represent areas. So for instance, in this lecture, what I'll show you is how to add a layer, a polygon layer that represents world population by country. So countries are represented as areas, and what we're going to do is each of the countries will have a specific color which will indicate the population of that country. So points for locations, lines for lines, and polygons for areas. Now, of course, you need to have some data to create a polygon layer. You know, just like as we did with markers, we had some data in CSV in text format, and then we use those data, we open them with pandas, and then we iterated through those lines of the data, and we added the markers to the map. Now, for polygons, the way to add polygons via Folium is by using the Folium.geoJSON method. So basically, let me make some space here. The way this would work is you want to add to feature group the variable here. You want to add a child, which will be a Folium.geoJSON object. So this is the method with brackets here that creates a GeoJSON object. And for GeoJSON data, we will use this world.json file. You can find this attached in this lecture. Let me explain what this is, but careful, don't open it on an Atom, because if your computer is a bit slow, your Atom may crash. So try to open it with a lighter editor, such as Notepad, for instance, or Cat on Linux terminal or Mac. Anyway, this is the JSON file. You can refer to it as JSON or GeoJSON. Actually, GeoJSON is a special case of JSON. Basically, the format is always the same. It starts with curly brackets, and basically it contains a string which is like a Python dictionary with keys and values. Keys, key, and value. Where this curly bracket ends, somewhere here, I believe, if I'm not wrong. No, this one ends in here. Yeah. And then you have the other key, geometry. So what is geometry? Well, the type of geometry is multi-polygon. So basically you have these kind of attributes that describe the data. Type multi-polygon coordinates. So this is now starting to describe the features, the polygons. So these are the coordinates of the first polygon that will be displayed on the map. Let's say this is one specific country, and that's Antigua and Barbuda. Yeah, a small country, but anyway. And these are the coordinates that will determine the location of that polygon in your map. So basically, Folium will read all this information and it will decide where to put the polygons. And then you can also use other attributes of this, such as population, which is here. Yeah, you'll use this population value to put a color for that population. And so on and so forth. You have all the countries of the world in this JSON file. So spend a few minutes looking at this file to understand its structure, and in the next lecture I'll go ahead and load the JSON file into Python and display the polygon layer. See you there. Great! In the previous lecture I showed you how a JSON file looks like, and in this lecture I'll go ahead and add that JSON file to the code. Remember, I provided you with the JSON file in the previous lecture. You could download it from the lecture resources. And so, this GeoJSON method gets a data attribute which is equal to the file object of the JSON data. So basically you need to create a Python file object which you can create with open. Remember, open is a classic Python method for creating file objects. So there goes the path of the file. This happens to be in the same directory with my map1.py script, so I'm just passing world.json. And basically you're opening it in read mode, and I'll leave it like that for now. Save, execute. I think we'll get an error here. Yeah, we need to add an encoding parameter there, as suggested by the error message. So that goes inside the open method. Equals to UTF-8 sig. Save again, go and execute. Reload. And yep, we have the polygons displayed on the map. So that was quite easy to do. And something you should know is that you can also add points through GeoJSON. So in this case we added polygons, but that JSON file could also have lines or could also have points in its attributes. So, you know, this one, we had an attribute that was stating these are multi-polygons, but this could be points or lines. And in that case, Folium will display those features depending on this type attribute in here. Of course, you'd also have the coordinates attribute with the coordinates of the line, so the points where the line breaks and turn. And in the case of points, you'd have pairs of coordinates here. So I hope you get the idea. That was about this lecture. In the next lecture, I'll show you how to create a choropleth map, which is a map that uses coloring of areas to represent features. In this particular case, what we'll do is we will have these polygons with different colors to represent the population of the world for each country. We'll do that in the next lecture. See you. Hi again. In this lecture, I'll show you how to make a country by population map. We'll be showing population of each country through graduated colors. So we'll think about a range of colors to represent population from low to high. And we have that piece of information in our world.json file, which is stored in this pop 2005 attribute. So pop 2005 means population from 2005, which is quite old, but it shouldn't be a problem for educational purposes. So let's get back to the code. And the way to change the color of those polygons, because by default we have this green color, and there's also transparency on the polygons. You can see the base map on the background. And so to change that, you need to access the style function argument. But I have messed something here from the previous lecture, which could cause some problems later. This doesn't have to be in round brackets, so delete that. And one here as well. So we have 1, 2, 3 open brackets and 3 closing brackets. Now it should be fine. So we need to add another argument to GeoJSON. This is the first argument, so data is the first argument, which ends in here. So add there another style function argument, and you can actually break the line in here. You are free to break lines in Python when the expression is inside brackets, round brackets, square or curly brackets. So in this case, this expression is inside brackets, so we are able to break it. And it's good to break it at the comma. So style function equals to. Now this expects a lambda function. Lambda functions are just like functions, normal functions, but they are written in single lines of code. For instance, let's say L equals to lambda. This is a lambda function, x in power of 2. Oh, sorry, I had a typo there. Not lambda, but lambda. Okay, another typo. All right. So L is a function here, just like you'd have a normal function, and then you can call L. You can pass a value like 5, and that will return 5 in power of 2. So as you can see, you can write the function in one single line. And this can also be useful in other cases like this one in here that you'll see in just a bit. So lambda x. This also allows you to write anonymous functions. So this function now, it doesn't have a name. Like here, I assigned a name to this function because I needed to call it later. But this one here, we don't need to call it later, so you don't need to give a name. So here, the syntax would be correct if I do just like that. So let's go ahead and do this. Fill color with a capital C, lowercase f, uppercase C, and that should be in quotes. Let's say yellow. Now, if you want, you can leave it like that. So save the script. Exit the Python shell and execute the script. The execution went fine. Let me check the map, reload. And you'll see that the colors of the polygons changed to yellow. So that's how you can change the attributes of your JSON file. So to say, basically you add another, you add this attribute, which is not in the JSON file. If you search for it, you'll find nothing. And so now you can play around with this by adding conditionals inside this dictionary, such as if x properties pop 2005 is less than, let's say, 10 million. So 10, 1, 2, 3, 1, 2, 3. So what I'm doing here is I'm saying that set yellow to fill color if X represent the feature, a JSON feature here. So if the properties, actually if the pop 2005 attribute of this attribute, which is here, this is pop 2005. I know this is a bit complicated. Let me toggle software wrap. So now I have all the text wrapped here in the view, and here pop 2005 is actually part of this dictionary up to here. So this dictionary, these are a set of properties, and this dictionary is the value of this key, of the properties key. So what that means is that, we are accessing the value of the properties key using this syntax, which is known in Python. Meanwhile, X properties, what that is X here represents features. So you are accessing properties from features. And on the background, this is a bit of a black box. But Folium, what Folium will do is it will go through all the features of all the polygons, and it will check if the value of pop 2005 is less than 10 million, and if it is, then it will set this this color to fill color attribute. That's more or less about it. I think it's better to put this green, so if it's less than 10 million, put it green. Else orange if between 10 million. Do the same thing here. Properties. Actually, you can break the code in here. So properties pop 2005, and let's put here 20 million. So these are just arbitrary numbers. You can put everything that you want, but that will affect how your polygons are classified, are colored. So for population between 10 million and 20 million, we'll get orange colors. Else red. So everything above 10 million will be colored as red. Okay, let me save this, and I hope this will work. No errors. Reload. We have US colored in red because it has a population of higher than 20 million people, and yeah, this seems to be working fine. Portugal has a population of around 12 or 15 million people, I'm not sure. So it's in the middle range of our classification algorithm. And yeah, that's more or less about it. And if you like, you can ask questions, and I'll be happy to help you, and I'll talk to you later. Thanks. Hi, and welcome again to yet another lecture on web mapping with Python and Folium. This is the map we built this far, and it contains a base layer, a polygon layer, and a marker layer. This is our code. Now, what I want to do in this lecture, I want to implement a feature that allows me to turn the custom layers on and off. With custom layers, I mean the polygon layer and the marker layer, because it's not possible to turn off the base map, at least as far as I know. And it wouldn't make sense to turn off the base layer. You don't want a blank page. So let's see how to do that. The key feature here is layer control class of the Folium module, which can be added like this. You want to point to the map object, and then you want to add a child, so layer control is added as a child. So Folium layer control. Now, this will not work, but I still want to execute this so that you don't make this mistake later on. So let me reload the page. You only see the base map here, no layers at all. The reason this doesn't work is that when you added layer control to the map, you still hadn't added the feature group, which is an object that contains the JSON layer and the marker layer. So basically, layer control will be looking for the feature group added to the map, but it doesn't find it at this point. Therefore, things are messed up. So it's important to put that after you have added the feature group layer to the map, right here. Save and execute again. Reload the map, and you see the layers there, and you see this box here. So map box bright, this is about the base map, and you cannot turn this off. And you also have this my map item here of the layer control panel. So this is the layer control panel, and you can turn on and off this layer. But as you see, this is turning off and on both the polygon and the point layer at the same time, which is something you don't want. So we go ahead and change that, and I'll explain why this happens. So this is happening because, you know, layer control, what it does, it looks for objects added to map with add child, like here. So you have added a child, and you have added only one child to the map object. Therefore, layer control will consider that object as one single item of the layer control panel. But that feature group object, it contains the circle markers, but it also contains the GeoJSON layer. Therefore, you need to change your strategy here. So how can you do that? Well, there may be different ways. One way is to actually create a feature group for volcanoes. Let's call it AFGV. So you add AFGV here, and then you want another feature group. Let me copy this line, paste it here. You want another feature group for population. Let's call this population. Let's call this volcanoes, like that. Change the variable name, FGP here, okay, FGV there. Add another child, which has to be FGP for population. Yeah, now everything looks good. So let's see if layer control will be able to read these two feature groups now. Okay, go and reload. The map looks fine. Volcanoes, working well. Population 2. So everything is working fine. This is a map. And yeah, if you were able to build this as I did, then good job. You can also choose not to use feature groups actually. So you could have added GeoJSON to the map directly. However, for this case, for volcanoes, where you are adding, you are executing the addChild method multiple times, in that case, you'd have one layer for every volcano. So you'd have added 62 children to your map object if you did map without feature group here. So that means in this control panel here, you'd have 62 entries, 62 layers, and that's not what you want. So feature group comes in handy in here. For volcanoes it is necessary, but for GeoJSON you could have used map here and everything would be fine. But for consistency, it's good to add both to specific feature groups. Volcanoes here and population here. So now this is the code, and I hope you enjoyed this program, and feel free to ask questions, and I'll talk to you later on. See you.